Yo, what's up? Hello there, people. Sorry for the long hiatus that I took from programming, but I think we're back. So, yeah, welcome to another programming video. Let's see here. Let's see what we have to do. So, today I wanted to show to include blah, 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 blah. Oops. Okay, so it's been a while. So this is gonna be a new video. Let's just sorry for I was gone for so long. I wasn't really motivated to do anything, but I am now. So let's see what we can do. So let's see. So we have gotten a task for the CS50X University course to do a substitution cipher program in C. So, So let me just include everything that we need. We will need C type as well. Let me just write all the prototypes on here. So this is basically what we'll need. It's everything. We're gonna be doing it completely raw. Like completely raw, like basically without any helper functions from the SCS50 library. So the problem goes that we need to implement the substitution cipher, and it takes in a command line argument. So we already know that we need something like this. So that is gonna be our command line argument. So vector v arg vector here. So it's a pointer. So it's just a double pointer basically. But I like to sort of describe it like here. So it's basically a double pointer. Essentially, it's a 2D array. So if we wanted to basically break it down, it's basically a string, which is basically just a array. So it's basically just a char array, right? Oops, char array like this. And it's 1 byte. So here we have, it's a char array like this. There are two ways you can describe it. You can describe it as like a star and then a variable, or oops, where is my or? You can put a variable. I'm just variable and square bracket. So this is two ways that you can describe like an array here. So array. So it's either this or this, whichever one you prefer. So if we gave this a string, essentially strings don't exist in C. It's basically just a char pointer. So this is basically what a string is. And from here we can see that it's an array, right? So it's an array of characters. And obviously a double pointer would be an array of characters. So there we go. So you can describe it like this. You can describe it like this, or you can describe it like this. So these are three ways that you can basically put. It's basically a 2D array. How is that a 2D array? Well, basically you have a 2D array basically saying that this is a char array of arrays of types char. It's a little bit confusing, but that's basically how this works. So there we go. So that's basically why this looks like the way it looks. So this will be passed in automatically. So we will basically need to say we also need to do some checks on the key. So the key, in this case, the key that we will use to encrypt this data will basically come from the arg vector here. So that's basically how that works. So we'll need to check if it's valid. And if it's invalid, we return a value of 1, else we return a value of 0. So that's basically what we're doing here. So it needs to be 26 characters, and it cannot contain any character that isn't an alphabetical character, and it needs to contain each letter exactly once. Whew, all right. So let's make our first function here. So this function will return an integer because it needs to basically give us a number that will basically tell us if the function was successful or not, right? So that's why it's an int. Let's do validate key, and let's say that this validate key function takes in a const char. It gets a key. So const char, our const char pointer here, this basically means a string. So if we break down what a string is in a simple terms, it's basically a const char pointer. Or alternatively, if you want to do changes, it's a char pointer. And alternatively, this can also be written as a char array or const char array. Oops. Char array. So choose whichever one you prefer. I like writing it this way. That's just my preference. But yeah, so let's see. So int validate key. So const char pointer key. There we go. So what do we actually need here? So the validation is pretty simple. So we need 2 arguments. But the first argument is just the path of the file that you're basically located in. So that's pretty simple. So we need 2. So basically we need to use the arg counter that's there. So if argc is not equal to 2, we want to basically print that. So usage, let's say usage is going to be substitution, and let's put key here. So there we go, and we return 1 as per the instructions because an error has happened. So that is going to be that. And now we need to basically validate the key. So basically what we will use is we will return 0 by default on success, and on error we will return -1. So let's see how we can validate the key here. So the theory behind all of this is that we get a key, right? Let's just say some random numbers like this. We have this key, right? That's basically 26 characters long. So it's 26 chars long, right? Now, it's 26 chars long, and the alphabet is 26 chars long. So what we have to do is we have to essentially create a mapping between the alphabet and this key. Now, native C doesn't support mapping. It doesn't have maps as far as I know. So we have to kind of map it manually. So basically we need to find the index of the key and see where at an index it is, because these represent like letters of the alphabet, and there's 26 of them, obviously. So we need to somehow map it between the normal alphabet and this scrambled alphabet, if you will. Okay, let's get back to validating the key. So in this case, validating the key. So first we need to check, let's say, we need to check the length. So first let's check the length of the key. So basically the key needs to be 26 characters long, right? So this is fairly easy. So you basically go if we need string, we have string, there we go. So if str length of key in this case is not equal to 26, I'm just gonna return -1 in this case. So this basically means that we have an error. And now we can basically validate. So if we can basically now put it into our main program and basically see, we can work with that -1 value. So this basically gives us the power. So argv1, because it's the second, the key is the second argument in our argument vector. And we can then say this is less than 0, right? So if this is less than 0, then we have an error on our hands. And in this case, we can print to the console that this is an invalid key. Right? Invalid key and return 1. So like this, invalid key. But this function can also do more things as well. So the instructions said also that it has to be 26 characters long. So this is basically like, we already done that. Let's see. So the key has to have let me see, has to have only alphabetical chars, let's just say. Okay, so let's check for that. So there is a function that you can use called isAlpha. So for this, so we can use isAlpha function here from, so this comes from ctype.h, I think. ctype.h, basically, I think so. So that comes from the ctype.h library. Okay, good. So let's see. So we basically need to loop. So what do we need to do here? I mean, logically, you could assume that we need to loop through the key, right? Because we need to check every letter and ask if it's alphabetical, right? Like, is this letter alphabetical? Is this letter alphabetical? So it would be a for loop, indeed. So int I is equal to 0. And then we iterate. We also need length, which is gonna be str length, which is basically something like this, as it suggests. Now we have to strictly say that this is an integer, just so we get rid of the warning. So we're basically truncating it down to an integer from size t, I think. Yeah, size t. So truncating down to an integer, which should work. So now we are only calling basically this function only once. And then we're just checking against the variable, which is exactly what you should be doing. So now we're basically saying that, like, check every number. So check every member of the string that basically exists and then basically is in the key, starting from 0 until 25, obviously. So this is gonna be this is actually kind of easy because it's just a one if statement. So if, so not is alpha, so is alpha key I, then what we want to do is return -1 again, right? That because we found an error saying that like, oh, it's not an alpha key. Oh, it's not an alphabetical character, so we have an error. Okay, so that's done. So now let's go and check for repeats. Now this one is going to be a little bit harder. So check for repeats in the key. Now the repeated characters can also be, so the problem here is that repeated chars can be mixed case. And this is the problem here. They can be mixed case. So we have to somehow ensure that we are comparing them in a constant way. So it's a for loop, obviously. So let's go int I is equal to 0. Obviously I want to put length, this one right here. So we are iterating through the entire key. Now, we have 2 for loops here. I'm looking at my notes here because this is quite a big project. So what do we want to do here? So basically we have this, we need to basically start at a position here, right? So let's look at it a little bit visually here. So we are starting at position 0. So if we have, so let's imagine that this is like chars, right? This is 1 byte, 1 byte, 1 byte, right? And let's say that this is like key K, E, S, F, R, T, right? So in memory, we have this string of, let's say /0. So we have this string in memory, right? That's null terminated. And here we basically need to check if each of these is somehow repeating in this memory, in this set, in this string, right? And it can be mixed case. So first, so we need to somehow be able to compare this character with this character here. So we are comparing K with an E. So obviously the problem is also going to arise when we like reach the end right here, basically length -1, right? Because then if we start at I+1, we will go out of the array and we can corrupt the memory. So what we want to do here is we want to check if so basically we're comparing it, right? So J in this case needs to start at I+1. Because if it starts at I, we will always get true when they equal. So if we assign J to be I+1, we need to be able to check if we are at the end of the string. So if I in this case is equal to length -1, which is the last letter of the string, we want to terminate the loop, right? So that's the theory behind it at the very least. I don't know if this is the best way of doing it. This is just the way I found out that we can do it. So basically we want to loop if I while, so we basically want to do, so if I is not equal to length -1, it already gave us the answer there. Then we want to do a for loop where int j is equal to I+1. So basically we want to do something like this. So j is equal to I+1. Let me move my camera somewhere a little bit better. I think here. Yeah, there we go. There we go. Okay, good. Let's continue. So in this case, basically here is where we're basically saying that if I is not equal to length plus 1, we want to run this loop, because what do we want to do here, right? If we are here, right? So if we are here, so we say I is this, I is k, and j is I plus 1, so that would be e. And then compare them together if they're equal. Okay, so let's say I is 1, we are at e. J is I plus 1, s. So I is 0, this will give us k. Let me just try and explain it a little bit better. So for the first loop, I is equal to 0, this will be, so we will get k. And then we will check if I is equal to length minus 1, which it isn't, which then we will get the inner loop, in which j would be equal to 0 plus 1. In this case, this would be 1. So in anything, so explicitly j is equal to 1. Now we compare them together, right? So I would be targeting the k and j would be targeting the e. Then we compare them together. Are they equal? No. No, they're not. Okay, so let's move on. J is 1. That would be e. I plus 1, that would be 2. So s, compare them, right? And then we're basically comparing every single letter. So basically compare these two and then compare these two, but j then compares for the rest of the string as well. Basically saying that, like, if so I is 0 would be the k, j then would be equal to I plus 1, which is e, and then the second for loop will iterate then through every single part, essentially, like, window here to find if there is a repeated character. Basically, that's the gist. It sounds very complicated, but it's really not. So if basically here, if we can just say that if key I is double equal to key j, double equal to key j, we return -1. Else we return 0. So we will basically go like is k, and then we'll start. We iterate first at I, which is k. Then we say j is I plus 1, which starts with e, and then we iterate through the rest of the string to find if there is a repeat. Then we start here and iterate again through the rest of the string. Start here and then iterate again through the rest of the string to find if there are any repeats. And when I is equal to length minus 1, we will simply just terminate the program, and we basically say that there is no more string left, then there are no more repeats left. So that is what that is. So that would be our validation key. So that would be our key, our validate key function here. So yeah. So this should then be a work. Now let's get user input. So now we need to get user input. So we will need to allocate some, we'll have to do some macros. Define, let's say we need a buffer. So buffer size. I like going, let's say 1024. And then define alphabet size as 26. So these are constants. They never change. I just like declaring my constants as macros. That's just personally the way I like doing things. Now, let's see here. So this function returns a char pointer. Get user input. And let's just, for the fun of it, prompt the user for a prompt anyways. So char pointer get user input const char pointer prompt. There we go. Okay, so here we have a little bit of a difficulty wall here, because to return a char we need to allocate it on the heap, I think. So we need to do a heap allocation. So let's do that. So char pointer, let's select input is malloc, and then we just say buffer size multiplied by size of char, and then we do memset input 0 buffer size, and then we just multiply this by size of char. So what I'm doing here is allocating a string on the heap here, so we can return it from the function basically. So that's what I'm doing here. So let's see. So now we need to get input, which is fairly easy. So let's go char c and int count, because we need to keep the count of how many chars actually are in this in our buffer of stdin buffer that we are inputting. And we'll just say while loop c equals get char is not equal to new line. So we basically want to say that it's not equal to new line, so we want to get characters until we reach new line, until we press enter basically. We can also say c does not equal to eof. No, it needs to be and, not or. And c is not equal to eof, and count is less than buffer size. So count is less than buffer size. So what then happens here? Well, we basically just load up the input with the characters and we increment count. This get char here into char, we can just cast it as a char. So we obviously then return the input that we have basically allocated. So we're basically, and here I can also do print fs string prompt. Okay, good. So we're basically allocating a string on the heap with this length, buffer size times size of char, which is 1, so 1024 times 1, which is 1024. We are zeroing it out to make sure we have an empty array of zeros. That will ensure that we will properly have a proper string. The count here basically makes sure that we don't overflow our buffer. So if the count goes above the buffer size, we basically abort reading from stdin, because we don't want to overflow our buffer. So that's why it's there. And then yeah, this is pretty cool. So then we return the input. So we return the input. Now obviously here we need to say under these if statements, we will basically say that we'll basically take the user input as plain text. So const char pointer plain text equals get user input. So get user input, and then the prompt could be, let's say, plain text. There we go. Now what we need to do is we need to free let's cast it as a void pointer, and then we can just say plain text. So we need to basically do this to make sure that we don't have a memory leak. So we can't leak our memory if we are allocating on the heap and returning it. We need to basically then free the plain text and make sure that we don't leak our memory. So now let's see if we can print it, let's say. So print, let's say the text is, and let's say s, %s, plain text. There we go. So let's see if this runs. Run substitution. Oh, we don't have the correct key here. So let me just grab the correct key that we need to input into this. So it's Okay, so we just need to input a correct key here into the program arguments. So that is NQX, NQX, NQX POM, POM, AFTR, AFTR HL, HL, ZG, CG, EC, CGEC, YJ, YJIU, WSK, DVB. Okay, so this should give us a working... Yeah, so now as you can see, we have plain text, and let's say hello. We get plain text. The text is hello. And it exited with code 0, so we have no issues here. So it passed all the checks, and yeah. So we know that works. So now we have a way to basically input the plain text into our little program here. So in a sense, we have the returning ones basically, and we are getting the plain text and returning it, which means that it works. We are getting returning ones, which is also something that is there. And yeah, so let's continue here. So that takes care of the user input in this case. So that takes care of that. Now what we have to do is we have to encrypt. So this one is a big function. So what I want to do is I want to return a string that is going to be the ciphertext, right? So what do we need here? So we need const. I'm going to actually prototype this function here as well. So char pointer encrypt, and we need two things. We need const char plaintext and key. So we need two strings. We need plaintext and key. Oops. So we need plaintext and key. Okay. So we're gonna do just like we did here, where we will basically allocate it. So, but these things need to be the same length though. Don't forget that the ciphertext and the input need to be the same length. That's the reason why I made this global variable here, buffer size. So char pointer, let's say ciphertext. There we go. And then memset ciphertext C0. So we do that. Okay, nice. So now we basically have the first one done. We also need to create a dictionary of some kind, or at least like a vector, a vector called alphabet. And here we'll use an initialize list, and we will basically just say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So we need something like this called alphabet, because we need something that we can basically compare the key to, right? So basically the key is an alphabet that is scrambled, and then we have the normal alphabet, just so we can like link between them in a sense. Now we also now this function here, so I'll also create a const int plain text length. I think we need, so text length, which will give us stir length. So we use this function from string, And here we'll just say return ciphertext for now. And here we'll basically have to loop through it. So we need to basically loop through the plain text and then get the positions of the letters in the alphabet, get the index of them, and then translate that index to the scrambled alphabet of the key. It's actually not that hard. So we were gonna, since this is called from main, I'm gonna say that if plain text is not equal to void pointer 0, so basically make sure that it's not null, then I want to do int I is 0, I is less than text length plus plus, and here now we will basically have to have another function which basically just helps us to find the index of basically whatever we're looking for. So let's create another function that is going to return an index. So find index, and it's going to find index. So we need the alphabet. We need to pass in the alphabet that we're using. Alphabet. And a single key C, char letter, and then here we need const in, oh, these don't have to be const qualified, char letter, and then here we will have an int length. There we go. So there we go. Let's just declare it here. And here we'll just say these can be const qualified because they don't change, so we can const qualify them easily. Now what we need to do is we need to basically find the index of the plain text letter in the alphabet. That what index is it at? So that's basically just one for loop. So we'll say I is equal to length. We have to pass the length separately, unfortunately. There's nothing we can do, but here we can basically go this, and then we can just ask if alphabet I is equal to the letter. I want to return I in this case. Let return I, else return -1. So this basically, if it doesn't find the letter in the alphabet, we're just returning -1. So we can then do const, let's call it idx, const int idx equals find index. And so now we have basically the alphabet. So we're going to pass in the alphabet. And we have the character we're looking for, which is going to be to lower, which is going to be a char of to lower plain text I. So I'm doing this because we in our alphabet we have lowercase characters, just to make sure that that will basically match with the alphabet that we have in our array. And here we can just say alphabet size. So this will basically give us the index or the position of the letter in the alphabet. So that would basically be like that. So now we basically, all we have to do is just append the letters and that we substitute to the ciphertext that we have allocated on the heap. So if idx is equal to -1, what we want to do is we simply just want to put ciphertext I is equal to key at idx. And this is basically where it becomes interesting, because we are basically using this to find the index, the position on the alphabet, and that we are basically using that to then get the letter at the same position from the key, right? So that's why we're doing it like this. So basically, we are searching. Oh, what's the? Let's say that we have a D in the plain text. Oh, the D has this position here. Okay, so what is basically at this same position but in the key, and then we basically just append it to the ciphertext, or basically substitute it for the one in the key. Now we just have to say if. Now we basically just have to make it like if it's an uppercase letter, we want to substitute it with an uppercase letter, and if it's a lowercase letter, we want to substitute it with a lowercase letter. With this is easily done, so we can just say is upper. So basically, I want to say if is upper plain text I and is upper key IDX. So if both or, so if they are both uppercase or both lowercase, so is lower plain text I, plain text I, and is lower key IDX. I just want to do ciphertext, so I want to append ciphertext to ciphertext, just key IDX. So we just want to append it, like there's no reason to change it. If they're both uppercase or both lowercase, then there's no need to change it. Else if, then we can have another option where is upper plain text I, and is lower key IDX. So in this case, so is upper plain text I and is lower. So in this case, we have an uppercase letter in plain text, but a lowercase letter in the key, which then we need to append a char of key IDX minus 32. So this is basically creating a char. So we're basically saying that if it's uppercase, then yeah. So if it's uppercase minus 32, we are converting the char in the key at the position index to an uppercase character. So we're appending a uppercase character here. Else if is lower plain text I and is upper key index. So if it's the other way around, basically we want to do the same thing but just add 32. So, and we return ciphertext from this function. So yes, so basically we have these ones. So now we have this, so it's not 2, so we need 2. We validate the key. Now we basically just have to do const char, so string ciphertext equals encrypt. So we're going to use our encrypt function. We're going to pass in plain text and the key, which is going to be in the argument vector 1. And obviously we need to free ciphertext to prevent memory leaks. So there we go. I think that should be it. So yeah, so let's go through this again. So we have a bunch of functions here. So we're basically checking if we have 2 arguments. If we don't have 2 arguments, we basically throw an error. We are validating the key, so we're basically checking if it's 26 characters. Then we're checking if it's alphabetical. So we're basically checking if it's like alphabetical, and then we're checking if there are no repeats. If all of this succeeds and we return 0, that means that we have successfully validated the key. Now we get user input. So get user input. We allocate on the heap, and we basically get the input from the std in stream until the user hits enter, basically. And then we're basically just inputting the characters into this array here. That's how we basically generate a string that the user typed in, which will then be returned to plain text. Now for the encrypt function, so the encrypt function also allocates on the heap the same size as the plain text, same length as the plain text, and we have a dictionary here of letters of the alphabet that we can link to. So we then get the length of the plain text, and for the length of we need to check if it's not a null pointer, and if it's not a null pointer, then we can start checking. Then we can just check substituting the letters, basically. So we start at the beginning of the plain text. We find the index, so we're basically looking for the letter inside our alphabet to check at which position should we substitute the letter. So that's what our find index does. So we just have alphabet to lower, because if the key has alpha mixed case characters in it, it can be a problem. So we just turn everything to lowercase and compare it that way. And then the length of the alphabet is just our constant alphabet size here that we've defined. So that's just there. If it's -1, that means it's not an alphanumeric, it's not an alphabetical character, which means we can just append it to the ciphertext unchanged. If is upper, then we need to check the cases. So if the letter is uppercase in the plaintext and uppercase in the key, or if it's lowercase in the plaintext and lowercase in the key, we just append it without changing it. So if there is an uppercase letter in plaintext but the lowercase letter in the key, then we need to subtract 32 and convert it into a character and put it into the ciphertext. If the character is lowercase in the plaintext but is uppercase in the key, we simply just like convert it to a lowercase character, I think. Yeah, lowercase character. So yeah, I think that should be it. I think that it should just run just fine. So yeah, so we basically have the buffer size of 1024 just to accommodate for really long sentences and stuff like that. So yeah, so here we'll basically check the AOF or buffer size, less than buffer size, to make sure it doesn't overflow. And yeah, I think we can basically test this program and see if it works. So yeah. So now we can basically run it, and let's say hello. Oh, but I'm not actually doing something here. I'm forgetting to basically print. So I want to say ciphertext is going to be ciphertext. There we go. Now we can run it and say hello, and we get full, which is not exactly what I wanted. Oh, this should be plain text I. Sorry. I should be plain text I. We have NQX. Okay, so that should be correct. Plain text key IDX, 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 IDX. IDX, IDX, IDX. Okay, we have this one, plain text. Ciphertext gets returned here. Let's see. Let's try and debug this here. So let's see. IDX. IDX. Let's see if our program actually works correctly here. 7 4 11 11 14. Okay, that's correct. Mm-hmm. So 7 4 11 11 14. So H is 7 0 1 2 3 4 5 6 7. Okay, so it is correctly assigning the indexes, which is obviously good. So here you have plain text is lower IDX. It should be text length. Yeah, so it is correct. 7 4 11 11 14. And then NQ NQ XP XP OM OM AF OMAF TR HL ZG E C Y J I U WSK DVB. Oh, it is correct. We're just having a different, we're just using a different key. We're just using a different key, and that's why we're getting a different result. Yeah, I think we're actually, I think this is actually doing it well. Let's try to do it with their key here that they say. So this should be working. So yeah, Fole is the ciphertext. Let me just check in our notes. There is another key here that they supply. So there we go. We have this key right here. So let me just switch the key just so we can like compare to like. So it's Y T N S H K V E F X R B A U Q Z C L W D M I P G J O. So this one should then print. This one should then print if it says hello ehababakwa. So hello ehababakwa. There we go. So it is indeed correct. So as you can see, we have ehababakwa. So, and if we go hello exclamation mark, we see that the exclamation mark gets printed unchanged. And if we say, for example, I love you exclamation mark, F buya jukuma exclamation mark. So there we go. As you can see, it works perfectly and we are not having any errors. So a little bit of debugging there, obviously. That's part of what you need to do. But yeah, so this is basically the program that basically encrypts to Substitution Cipher. So again, we're checking if it's 2. If not, then we are basically getting the input from the user and encrypting it. And there we go. I've already explained it. So yeah, I think it's been great. I had a lot of fun. So this is probably one of many solutions. I think that you can probably do it better. This is just a basic solution that I came up with that logically made sense to me. So, you know, this is just an example. So take it with a grain of salt. But yeah, so this is how I would basically go about programming a substitution cipher in C. So hope you enjoyed this video. Hope you learned something, and yeah, I'll see you in the next one. So yeah, see you later. Bye everyone.